Good evening, guys. So today we are going to start with two important topics. So today's Kubernetes day 16. So today we have to complete two important topics, which is Kubernetes volume and RBAC, means role-based access control. So both are very important topic. Okay, if you see Kubernetes, almost all the topics are important, right? It's not like that. You don't say that any one topic is easy or it is not been asked. It's not like that. Kubernetes, almost every topic is important. But these two are important topic which usually it is asked in an interview many times. They tend to ask many of the questions in volume as well as even in RBAC. RBAC means rollbacks access control, right? But when I went through some of the interview, mock interview, or is the real interviews and all, right? Some of the sessions which I have gone through it, and I have tried to understand like what are the questions they ask in Kubernetes, especially. And in RBAC, out of some 20 interviews, I have seen some 4 interviews. They've asked some few questions on RBAC. The rest, all other interviews, right? Like the rest 16 interviews, I don't see they've asked anything on RBC. But RBAC is a very, very important topic because it's a user management topic. Means you want to create a user account, you want to give some kind of a permission to the user account for working on to the Kubernetes cluster, right? So RBAC is very important. So it's kind of a user management. It means that if you are a Kubernetes administrator, you will be playing around every day with RBAC actually. Even with volume also, if you're a Kubernetes administrator, you will be playing with a lot of times with a volume also. Okay, now, so let us start now with the Kubernetes volume. So what exactly a volume actually, like what is Kubernetes volume? So if I go with the diagrammatic format to understand, so let me open MS Paint. Guys, hope the volume is clear. Is it laudable or the volume, sound is low? How is the quality of the volume? Are you able to hear me clearly?
Yeah, able to hear Rajesh.
Yeah, great. Yeah. Okay. So we know very well that we have a Kubernetes cluster. We have a Kubernetes cluster, and within the Kubernetes cluster, we have what we have. We have a nodes, right? We have a node. So we have master, worker 1, worker 2. We know this very well. We have a master. We have a worker 1 as well as we have worker 2 node, right? Now, you know that whenever in this Kubernetes cluster, whenever I create a deployment, it creates a pod. We know very well, right? It creates a pod, right? Usually what happened, right? Whenever it creates a pod, basically what happened, right? The Kubernetes will allocate some kind of a memory or some kind of a volume to it actually. A default volume it will be given, or it is something like a storage it will be given, if you want to say like that. So basically the type would always be an empty DR. This will be the volume always. So this is a basic storage which is given for each and every pod, right? This is a basic storage which is always assigned to pod actually. Now, this is one type of volume actually. The volume type is MTDR. Now, what happens that actually that whenever the pod want to do some operation, suppose like the pod is doing, it is using some wget or it is doing some like a curl. So basically, you're doing a wget or curl to download anything, right? So what happened, right? Whatever you are downloading it, right? Those data will be resided or will come and will be there in this volume, right? It will be there in the volume. So that whatever the data which you are downloading or whatever the temporary data is there, that would you will find under the ephemeral volume actually. This is a default volume which is given by each for each and every pod. Okay. So now what happened, right? Actually, So even like this data, whatever you have a volume, right? Suppose this pod is running actually during the runtime, during the runtime, during the runtime, the pod is generating some data or log. Even those data also which will be resided in this ephemeral volume actually. So if you see for each and every pod, now what happened, right? As soon as the pod get killed or the pod will get terminated, even all the data, whatever the data is there, right? All those data which are there, ephemeral, right? That will get wiped out, or it'll go off actually, right? It gets deleted, all those data. So then, because if you have created a type which is called the deployment, we know very well that one more new pod will get created, and that pod again will have a kind of a ephemeral. What happened? It will have some kind of a ephemeral storage assigned to it, actually, right? So now, but what happened? Whatever the runtime data was there, that you have lost it, right? Right? You have lost those data. You cannot recover back those data. So hence they say that. So why it is that because there is no persistency. It means that persistency is something like which is stored in a file system. We say. So what we say, why this data is gone? Because this data is not persistent. It is in memory. Okay, it is not saved into any disk. If you want the data to be saved, you want to make the data as a persistent data, right? Persistent means what do you mean by persistent data? Persistent data is permanent and stored in some file system. You have to say. That's it. So here what happened, right? This volume is not a persistent volume. It is just a ephemeral storage. Like by default, it is like a on fly in memory. No storage is given for each and every pod actually. Correct. But this is not a permanent storage actually. Hence, what is happening? That suppose you are having a pod which is actually having running some kind of a database, right? So for the database, always you have to have a volume because database might be writing so many data, right? So you want to save all those data, whatever the database doing, right? Those data can be saved into a persistent volume. It means that you need a definite volume where you can have a data to be where the data can be saved actually. So that is the reason what happened, right? We have something known as a storage volume actually. We have something known as a storage volume. So here you have a storage volume, right? Now, what will happen that what are the different types of storage volume we have? We have something like you have known as a local drive, local hard drive. It means that each and every node, it has its own drive, right? Hard drive, right? Hard disk is there, right? Suppose this node is having 500 GB. Sorry, this node is having some 500 GB. So this is the 500 GB. So let me draw the diagram actually. So this is the node. So this is my permanent storage, sir. This is the 500 GB hard drive is there. So this is my 500 GB hard drive. 100 GB hard drive is there, right? Now what is happening that this is the 500 GB hard drive. Now what will happen that yes. Now what happened, right? Whenever any pod is getting created, whenever any pod is getting created, whenever any pod is getting created, whenever the pod is getting created, you can attach this your local hard drive 500 GB to that pod, so that whenever a pod is trying to save any data, write any data, that those data can be saved inside this storage, inside this local drive. Yes, here what happened, right? You are able to achieve this persistence, right? Because the data is stored in the disk, or it is stored into the drive, or it is stored into the file system. So now what is happening that now the data is there. Now again what happened, right? Assume that this pod somehow it get killed, correct? So because of this deployment, what what the Kubernetes will do, Kubernetes is going to create one more pod, right? A new pod will get created. Again, what happened, right? This new pod, it can attach this local drive or local volume to this pod, so that again this pod, running pod, it can retrieve the data. So yes, it is. This is correct. This is the best way. It means that actually instead of having, uh, you know, ephemeral storage, which cannot save any data, which is then in memory. Now you can have a persistence by maintaining a local drive, and we know that in each and every node we have some kind of a local drive. This is fine. But the problem we are here with the local drive is that again, assume that this pod is created, it is running fine, and it is accessing this local drive, that's fine. But assume that this pod will get killed or it get terminated. Now a new pod will be created, which will be in worker 2 now. Which will be in worker 2. Now this 500 GB, which is there for this worker 1, this cannot be mounted to the worker 2. This cannot be mounted into the pod which is running in worker 2, right? So it's not possible because this drive, it is specific to the worker 1. Similarly, you have one more drive specific to the worker 2, right? But you cannot mount this drive from the worker 1 to a pod which is running worker 2. So here in this case, what happened, right? This local hard drive is not feasible to have the persistent data, correct? So this is a drawback, one of the drawback of the local hard drive. But if you make sure that, okay, with the help of an affinity or to some way, if you say that no, Rajesh, even though I'm maintaining a local hard drive, okay, the pod which is running it, even though the pod will get killed, I will make sure that one more pod will get created into the same worker node and not allow it to happen into the other worker node. So then what happened? I would suggest you to go with your local hard drive itself. But what happened, right? There are again a lot of disadvantages are there. Okay, assume that this local drive itself got corrupted. What happened? Assume that this whole worker 1 itself got terminated. So you're even losing your drive. You're losing even all your important data, right? So in that case, what is happening is that actually it is always better to go with the network file system or network hard drive. So what is it? You have to go with your network file system or your network storage, you have to say. Correct? You have to go with the network storage. In network storage, there are different storages are there. The most commonly used storages are, like, let me write down here. The most commonly storages are NFS, network file system. You can go with the iSCSI or SCSI drive, okay? And you can go with the AWS S3 storage, or else you can even go with the EBS, Elastic Batch Storage. Similarly, you have Azure storage. Similarly, you have a GCP storage, GCP, Google Cloud Platform Storage. Similarly, you have Red Hat's cluster storage. Like this, there are many storages are there which are provided by many different vendors actually. So all this act as a network storage actually, network storage, and each and every storage has a different specification or usage and all. So now what you can do is that actually that here what we can do that we can in our today's session, right, we can create one NFS, NFS, you can create it, okay? And that NFS, what you can do, right, suppose this pod is running, so I can attach this network storage to your pod actually. So this network NFS storage I can attach to your pod. So whatever the pod is writing the data, finally it will be writing this data to this NFS storage, right? Assume that this pod will get terminated, a new pod will get created. Again, what happened, right? The same network's NFS storage or NFS personal storage can be again mounted back to this new storage actually. Similarly, assume that you are having this worker 1, worker 2, or whatever, how many, whatever the pods you are there, you can have multiple pods created. Suppose you're creating a replicas. Here you have deployment, but within a deployment you can create replicas, right? So in replicas, you can mention that, okay, I have an NFS storage, network storage. I have an NFS storage, network storage. I'm sorry, what happened today? Okay, NFS storage you have. This is the NFS storage. This is the NFS storage. What you can say that Rajesh, can we mount this NFS storage to all these 3 replicas of pod which is created? Yes, you can actually mount it like this. It is possible. Okay, so here what we are going to do today is that we are going to understand about how exactly NFS has to be configured. Okay, how we can use as a persistent storage when it comes to NFS. If you understand any one working node, so suppose if today we are working on NFS, tomorrow if you're trying out with AWS S3 or EBS, right, the process is same, but here and there some few steps will get changed. But if you are perfect in any one, right, understanding the other network storage, right, it will not be that difficult. The process will be same, but here and there some few commands would get changed actually, which you have to understand actually. Okay, so this is what it is actually. Okay, so here what you are doing that whenever you are creating an NFS actually, NFS storage, this NFS storage has to get mounted to your pod actually. It can only be mounted if your storage is nothing but if the storage should be something like a PVC. PVC means persistence volume claim. If it is a persistent volume claim, then only this storage will be, it can be attached or it can be mounted to the pod actually. So it means that whenever you're creating a storage, first after the storage is created, first you have to create a PV actually. First you have to create a PV. PV we call it as a physical volume, or you can call it as a persistent volume. Once you create the persistent volume, then you can create a PVC. Out of PV, you can create the PVC, and then this PVC can be mounted to any of the pod actually. Okay, storage has to be created first, then you have to create the PV persistent volume, and on top of the persistent volume, you have to create a persistent volume claim. This is same thing like an LVM, right? What we create in Linux, right? We have an LVM volume create, right? So that's the same concept, sir, actually. Now to make you better understand actually, like I can open one more MS Paint. So now you know that in Linux actually, in Linux, we have something as a LVM, right? What is LVM? Logical Volume Manager. Logical Volume Manager. So what is Logical Volume Manager means? Basically, suppose you have a storage actually. So suppose I have a storage like this. There are 3 storage devices are there, or 3 hard disk drives are there like this. Each hard disk drive is 10 GB. 10 GB. Sorry, excuse me. What I have to do that, I have to create a volume group actually. I have to create a volume group. I have to create a volume. This we call as a VG. This we call as a VG. We call it as a volume group. Okay, and all these 3 disks, right? This has to get added into the VG actually, volume group like this. Clear, sir? So this volume group will be of a size now 30 GB, correct? Because 10 plus 10 plus 10 total will be 30 GB. Now out of this 30 GB, now I want to create an LVM. So you have to create, we call it the L wall or logical volumes. We say we say it as a LV, logical volume. LV, we call it as a logical volume. Okay, so you say that, okay, Rajesh, I'm trying to create some 5 GB, of your L wall. So basically what will happen that out of this 30 GB, 5 GB will be allocated for this L wall actually, right? So 5 GB will be allocated. right? From the out of this 30 GB, 5 GB will be assigned to this LVOL actually. So you'll give some name for that actually, right? So this is same. This is nothing but the LVM concept what is on Linux. Same thing. What is happening that in case of your storage here, because we are taking from the NFS storage, right? So here this will act as a NFS actually. This will act as a NFS actually. This will act as a NFS. So NFS is something, it's like a storage. Within the NFS, what is happening is that we have to create the PV. PV is not but persistent volume. We know that. It is same as your volume group. What we have VG, right? Same thing. Persistent volume. Right? Same thing as your persistent volume. Right? So here what happened, right? You are going to create the persistent volume from your NFS. And here L is nothing but it is your what? It is your PVC actually. So PVC is same as LVS like this. So this is not but persistent volume claim. Correct, sir? Persistent volume claim. If somebody asks you what is the persistent volume claim, you have to say that it's the same thing as LV what we have, logical volumes what we have, right? In Linux, it is same thing in case of a storage network drives, we call it as a PVC. So what is persistent volume? It is same thing as your volume group, what you have in LVM. Clear, sir? From here, what is happening is that actually from the persistent volume, you try to create a PVC of 5 GB. Clear, sir? Any doubt you have until here? Any doubts?
No, Rajesh.
No, Rajesh. Okay. Now, so what we are going to do now is that, guys, so we are going to create one NFS server, and in the NFS server, we are going to create the physical volume as well as a PVC, right? We are going to attach it and we are going to see how exactly NFS works actually. Right, for that, what I will do, like I basically have a master and a worker node. If you go to my system and if I say kubectl get nodes, you can see that actually that I'm having master and worker one. Okay, fine. Now what I can do that I can in the master itself I can configure the NFS actually. I can configure the NFS in the master only, so that when the pod is getting created, I want to attach any storage. That storage will come by default from the NFS itself, from the master itself where I have configured NFS. So, but I don't want to do that. I will do one thing. I will no. I will try to create one more server actually that I will act. I'll make it as a NFS server. So for doing that, I will let me launch a new instance. So here, what happened, right? Here, what I will do that I will take the Ubuntu itself. But here in this case, what I will do, I'll not go with this micro, even though it is a T2 micro, because even though it is a free tier, I'm only getting only 1 GB, sir. I don't want to go with that actually. I will go with minimum for T2 medium, that is 4 GB. It means that I want at least something 2 GB as a as a PVC I want. So I can go with this, or else you can go with the higher also 8 GB, 16 GB. But for our for our lab accessory, we don't need that much of PVC. I'll go with the T2 micro itself, T2 medium, sorry, T2 medium itself. I'll go through it. Storage. So I'll just go with the name, or something like NFS server. Okay, I'll go with some name actually. I'll select the volume. I'll go select my security group. I'll go launch here. Okay. So let it come up. Why it is taking so long time? Oh, basically within 30 second, like the server will come up. Sometime it happens, guys. Actually, what happened, right? Sometime what happened, right? You will take some instance, and like even after 1 minute, it will not come up actually. Then in that case, what happened? That you immediately terminate it. Immediately you terminate it, and again you create one more instance. Actually, don't wait for a long time. There's no there is no use of waiting. Sometime it happens, rarely. For me, it has happened one or two twice in times it has happened. But I'm just telling you. Okay, so let me log into the server actually. So okay, so I've logged into the server. Okay, so I'll better switch to the super user. Sudo su-root. I switch to the super user. If you want to set the host name, you can set the host name. Host name, ctl, set hyphen host name. You know this command we have been executing. NFS hyphen server, something. We can set the host name also. Can even execute bash, see that your host name is set to NFS. Now, what I have to do that I have to configure the NFS actually. So to configure the NFS, you can go to the Google and you can say that how to configure, how to install NFS in 18.04. You'll get many articles, sir. Like you'll get TechMint and you'll go to the DigitalOcean. Always, it is always best practice to go with the DigitalOcean. So they'll give some elaborate information about that. Even you can go with the TechMint also. They will give you the information about how to install and everything. So, but if I go with the DigitalOcean site, right, they will give a lot of other information actually. So they'll give the prerequisite and all, and then like if you see right here, they're saying that sudo apt-get update actually. So I have to install, I have to just run first. I have to update the package sudo apt-get update. Then what it says that you have to say sudo apt-get install nfs-common. Here you could say that sudo apt-get install nfs-server, nfs-kernel-server. If you install it by default, even nfs common also will get installed it. So you can just copy this. Okay, sudo apt-get install. Even you can use specify -away option. Here you're installing it. Okay, so it is getting installed. You could see that NFS has got installed now, right? If you see the NFS has got installed now. Okay, NFS got installed. So you have installed this package. Fine. After that, you have to create a directory here. You have to create a directory. How to create a, suppose I want to create a directory or I want to create a shared drive. So I'll do mkdir -p. I'll just create under /common/volume something. I'll create. Okay, I'll create it, and I will give the permission also like this. Okay, guys. So I have created a directory or something like a volume, which is /common/volume. Okay. After that, what he says actually, he will say that create a link and all soft link, which is not required. Chown, it's not required. So I need to create it. So you have to go with the etc exports actually. So I can go with the etc exports file actually. If you open it, by default, it shows you some of the things actually. Okay, this is good. It is showing me an example here. So I'll do one thing. I will edit it. So what is a drive? So I've created /volume /common/volume, and here I will say star and open, and you can just copy this line, sir. Actually, here if you come down, see rw sync rw root cache, you can copy. You can even copy fully. So I want up to here actually. So I'll copy it like this. I'll just okay. Then what will happen that then you save this file. Here, sir, you have to open the etc exports, and then inside this file, you have to just specify what is the volume. Okay, which volume you have to make it as an export actually, so that /common/volume, and here you have to give this permission. Star means here basically, here what happened, right? You're not specifying the shared drive to be seen by only one particular server or one particular IP. Any IP address or any server or any IP address can actually look into the volume or can mount the volume. That's what here you are mentioning star. Assume that here you say that Rajesh, you are having a master node. Only a master only can view this shared volume. Then what has happened that here whatever the IP address is there, right? This public IP address. This public IP address you can assign it here actually. It means that only master only can mount it. Worker 1, worker 2 or any other will not be able to mount it actually. But here I'm mentioning as a star, it means that any IP address or any server can mount it actually. And this is the permission. So after mounting, you can do a read write onto this drive. You can do a sync operation, no root crash. So these are the things which are there actually. Okay. So once you do it, you have to save this file. So once you save it, actually, you come back to this document. What it says that you need to restart it actually. See, sudo systemctl restart or sudo system. I can just say start NFS kernel-server. So this is the way to start the server actually. Again, you want, and you can even enable it also. Okay, sir, you enabled it. It means that after you reboot your machine, the same server, if you reboot it also, the NFS by default will get restarted while when it is booting up actually, right? That's what we make as the enable. Okay. Now, if you want to see it, okay, you can execute a command export fs -v option. Okay, so you can say that why it can say restart actually. Restart it, and then you can say export fs -v. Now it will show that this common volume it is a common shared drive and it is mounted actually. See, star means world, anybody can access it, and this is what it can do onto this storage actually. Okay, so till here what happened, right? You have configured the NFS. Okay, sir, any doubt you have till here how to configure the NFS and all? It is easy, right? Only you have to install some package and then install NFS-server package, and then like you have to just create on volume or create on drive and give the permission. In DTC exports you have to just add that line, and then you have to restart it, and then you can check whether it has been exported or not with export-s export fs-v command. Clear? So that's all. And because here what is happening now, guys, you are into the cloud actually. You need not to worry anything about your firewall settings actually. Okay, firewall settings you do not to worry about. Suppose assume that you are working in your local drive, like suppose, sorry, you are working in your on premises, something like you have installed the machines in VMware or in Oracle VMbox, VirtualBox, right? There, if suppose by default any firewall is set up, or you need to do the settings over there actually. Here it is not required. Clear, sir? Any doubt you have till here?
No, right.
Okay. So now, what you will do now? So now, what you are going to do now? Now you have to create the PVC now. Okay. Here, if you go to the documents, are like persistent volume Kubernetes, like anything you can type Kubernetes persistent volume. These are official documents, sir. You can go through this document. If you come down here in this document, they are given all examples also, right? And I was just saying about this, right? What are the different storages, network storage you can have? If you come downwards, they are given clearly. See, where is it, sir? Yeah, types of persistent volume. See, AWS Elastic, EBS, Azure Disk, Azure File, Cyphers, cluster file system, which is Red Hat, as I was saying, cluster file system. iSCSI, which is very important and very popular. People are using most of the time iSCSI or NFS actually, right? And Cinder and all, I think it will be, Cinder is there actually. So it is OpenStack's Cinder. It will be deprecated actually from this. So no support will be given in the future by the Kubernetes actually. But these are the most, most used, persistent volume which is used actually. Clear, sir? Now, here what is happening that you have created now you are having a NFS server where your NFS has been configured. Okay. Now what I have to do that? Now I have to create the persistent volume, actually PV you have to create. If you come here, like I want to create a PV now, persistent volume I have to create. How to create that? So for that, they've already given an example. If you come up here, sorry, persistent volume. Okay, not this one. Where is it, sir? I think I have to come down. Persistent volume. Yeah, can use it. Here it will be there, sir. Yeah, this is the example, sir, actually, persistent volume. Okay, so let me do one thing, let me copy this actually. So I'll copy it, I'll go to the master, I will say pv.yaml. I'll go to the insert mode, I'll copy it. Okay, sir? I'll copy this. If you want, you can add that hyphen starts with 3 hyphen, right? Now, you see this example. Now you could see one more thing, guys. If you see that actually on the other days and all, right, what happened, right? Whenever I used to create a file with this, right, what happened? Whenever I paste it, actually, it was not pasting in an order way, right? Why? Because right, there was a auto indent missing was there. What I did, I created a file with the name .vimrc actually. You have to create a file with the name vimrc, or if it is there, open that file, just to set this line, sir, set auto indent, and save this file. Once you save this file, open that vimrc. Again, I'm telling you, write this set auto indent, set space auto indent, save this file, and just say source actually. So once you source it, now you open any of the file, pv.yaml. Now you can copy this, go to the insert mode, paste it. Now it will paste in a proper manner. Okay. So I'll do one thing. I'll just add this 3. Yeah. Okay. Now, so you could see that here that we are having an API version v1 and the kind is persistent volume. Fine. In the metadata, you are giving some name. So I will give some other name here instead of this name. I'll give something like my volume. My volume. So it means that whenever the pod is getting created, the pod will have this name my volume. Fine. Now, if you come down here, you could see that the capacity here spec under the spec you have a capacity and you are having a 5 GB here. Because you know that actually my T2 medium, right? This T2 medium by default it will get the storage as 4 GB actually. So I will not be able to use 4 GB because the server, the machine itself is providing 4 GB. How I can use 5 GB? So I'll make it to 2 GB actually, or I can even make 3 GB also. But okay, to the safer side, I'll make it as a 2 GB, 2 GI. And the volume mode is on the file system. The access mode, it means that whenever that storage, whatever that PV persistent volume, whatever you are creating, right? That what kind of an access you are giving it? You're giving a read write once access. So here, what you mean by read write once access means actually, if you come down to the document, in the document they have given the access also, access mode they are given. What are the access mode? See, read write once, read only many, read write once pod. If you come down here, you could see that read write once, read write only, read write many, and read write once. So what we are using here, read write once actually, read write once, RWO. So read write once, what it says, the volume can be mounted as a read write by only a single node. Read and write once access mode still can allow multiple pods to access the volume when the pods are running. So what is the meaning of this means actually? Basically, if you come here and if you're having this, even though this storage or under this PV or PVC has been mounted to the 3 pods actually, and if this PV is having the access mode as read write once, it means that at a time only one pod can actually do an operation onto this actually. The other pod, it cannot do the operation. There would be some kind of a synchronization mechanism. If you're using ReadWriteOnce, what will happen that one pod will be doing some read and write operation, and if the other pod is trying to do write, it cannot do it will avoid it actually. Basically, there will be some kind of a locking mechanism will be there. So if this pod is trying to do an access or try to write something into this persistent volume claim, then what happened, it will obtain some kind of internally it happen that it will obtain some lock, and after it obtains a lock, what happened, right, it will try to do some kind of a read and write operation. It will be doing some write operation onto it actually, like this. Sorry, something write operation like this. But the same moment, if the other pod is writing, right, it cannot write it because it has to obtain a lock actually. Once this pod completes that operation, it will release that lock so that any other pod can do a read and write operation like that. So there is some kind of a synchronization mechanism is happening over here actually. That's the reason what is happening, that if you use this ReadWriteOnce, actually only one pod can actually write at a time actually. But you can mount that, you can mount this PVC into many of the running pod. That is possible. That's what he says in the document actually. Read only many, the volume can be mounted as many as a read only by many nodes. It means that if it is read only, there is no write operation, only read operation. If there is a content here in the NFS shared drive, all this data can be read by each and every pod, but the pod cannot write into the storage actually, because you have given a access mode as read only like that. You have given the access. So I would say that better you go through this document actually. Okay. So after this, if you come here, what it says that persistence volume reclaim policy. So it means that actually what it says that, suppose assume that here in the diagram, if you go that, if you try to remove this PVC actually, if you try to remove this PVC, if there is some data is there in this, right? If you are using the recycle as a policy here for the persistent volume reclaim policy, if you remove this physical PVC, right, this data will go off. It means that you cannot claim back again that data. You cannot retain that back data. Those data will be gone. So what will happen, that this PVC again it will be freed up and it will go. Suppose if you are using a persistent volume reclaim policy as retain actually, even though you are deleting the physical volume claim actually, this PVC will get cleared, but the data will be remain still, it will be there in your persistent volume actually. Later through some mechanism you can retrieve the data. Correct, sir? So there are three types are there. One is a recycle, and other is a retain, and other is a deleted. So that also you can see it here. If you come down here, you could see that actually they have given the reclaim policy: retain, recycle, and delete. Retain means manual reclamation. It means that if you're using retain, even though you are deleting the PVC, even though you are deleting this PVC, right? Still what happened, right? The data will be there in your volume, persistent volume. Somehow you can retain that, you can recover back the data. But if you're using the recycle or delete, right, this cannot reclaim the data. The whole data will be removed actually. This delete is basically used for your so now after that, you could see that here the storage class name, it's saying storage class name is slow something. Now what is happening that here you are having one persistent volume. Assume that you are having a lot of persistent volume are there. Like here also one more persistent volume is there. Here also a lot of persistent volumes are there, right? Now when you are creating a PVC, from which PV it will try to allocate the PV. You have to give the name, right? Suppose assume that here you are giving the name as PV1. Here you'll give the name as PV2. And here you'll give the name as PV3. Now you say that, Rajesh, when I'm creating a PVC, I want the PVC from PV1. When you're creating a PVC, I want from PV2, PV3. Here you can specify the name to get the PVC. Okay. Suppose that while creating a PVC, you're not giving any name. How the system will do, right? Wherever the free disk space is there, right, the 5 GB, whatever you want to allocate, right? From whichever available PV is there, right? From that PV, it will take and it will create a PVC. But if you're explicitly mentioning the name, from that PV only, it will try to allocate the PVC. Clear? Here you're giving a name as a slow actually. Internally, it is using some name as a slow actually. So what I will do here, I will change the name here from some slow to something like I'll use the same thing, my volume. What happens, sir? My hyphen volume. Okay, sir. Now here, okay, mount option, it is hard. You want to use NFS version of 4.1, fine. And here you are using the path actually. Basically, the path here is what? Path is, what is the path? You know that under your NFS, right? You created a path of /volume, right? And what is the IP address? So here, basically what happened, right? You have to take the IP address of your NFS, right? So here, if you go, you are having a public and you are having a private. You can even use a private also, because all these three servers are created under the same zone actually, right? Same zone. So you can create, because all these three can communicate each other even with the private IP. But okay, to make it safer side, I will use a public IP. Okay, I will give the public IP over here. So this is a public IP, sir. What is a public IP? 23.23.23.218. So this is a public IP. Okay. So let me save this file. Here, sir. Now what happened, right? If you execute the command kubectl get PV. Hold a second, sir. I have to. This is what I'm creating. This I'm creating a PVC, not PV. Sorry. So this is the PVC, PV I'm creating, persistent volume I'm creating, right? So you're creating a pv.yaml, correct? So when I execute the command kubectl get PV, now you could say that there's no resource found. Okay, now already you have created a pv.yaml. So let me do one thing. Let me update, or let me apply the pv.yaml. Kubectl apply -v and say enter. Now if you see that kubectl get, and if you execute the PV persistent volume, now you could see that you have created a persistent volume with the name my volume, and the capacity is 2 GB, right? And the reclaim policy is recycle. The status is available. Claim, nobody has claimed now till now. Okay. And the age is 9 seconds. It just took 9 seconds. Just now, 9 seconds back, we created like that. Okay. Now, after you create the PV, now you have, so you have created the PV now. Now you have to create the PVC, because ultimately the pod, what are the pod running pod, right? That can only mount the PVC, not PV. Okay. So out of PV, you have to create a PVC now. Okay. So to create a PVC, sorry, you have to come down in the same document. If you come down here, here you have a, see, persistent volume claim. See, this is what the example actually. So you can copy this. PVC.yaml. Okay, I'll do one thing, sir. I don't want the selector and all, so let me remove these lines. I don't want this. Okay, and here at the top, I can add that hyphen. Okay, sir. So here, what you're doing here, the YAML file, API version v1. Okay, the kind is persistent volume, and here, what is a metadata? So what is a name you have to give? So I will do one thing. I will change the name as my something volume claim. Okay, and then the access mode is read write once. The file system is volume group is volume mode is file system. Okay, resource request the storage here. Now you know very well that in my PV, I have created a PV of 2 GB or 2 GI. In the PVC, I can max create 2 only. I cannot have 8 or 7, right? Because there is no space itself, right? 2 GB is there. You can even give 1 GB also, because you have to use always equal to or below 2 GB, right? So in this case also, what I will do, I will give is a 2 GB only. Okay, I'll just replace from 8 to 2. And the storage volume name, what is the storage volume name? The storage volume name is my volume, right? Because that's the name I have given, right? Right. So I have to say my volume. Clear, sir? Now I will save this file. Okay, now I will just apply it actually. kubectl apply -f and specify PVC. Yeah. Once I apply it, now if you execute the command kubectl get PVC, let me clear the screen. Now you could see that actually you have created a pod with the name my volume claim. That's the name of the pod. It is using the wall my wall actually. It is having a 2 GB. See, it is the access is read write mode, right? Now if you execute the kubectl get PV, here the claim, oh, it has been already been claimed as a default as a for the my volume claim actually. It has been already claimed now, right? So now what happened, right? Now I have to write a deployment where the deployment will try to mount this PVC, my volume claim PVC. It will try to mount it. For to do that, actually, what you can do that I can basically go with the WordPress application. Okay, so what I will do here in the search, right here, I'll here what happened. You could see that deploying WordPress with a MySQL with persistent. Okay, so I'll just click on this, and if I come down here, you'll see an example actually.
Rajesh bhai, like last 6 to 10 seconds, there was a like lag. I don't know
Okay,
anyone first.
okay, fine. Till where you understood, right? You did understood about the
Yes, yes,
PVC and
this one I
PVC.
got it. This one, the moment you went to that Google Chrome, I
Okay, okay,
lost
yeah,
it.
yeah, okay. So here you could see that I'll repeat it again. If we executed the kubectl apply -f PVC, you got the PVC. If you execute the kubectl get PVC, you got this PVC, right? Till here you're clear?
Yes, yes,
Okay.
Rajesh.
Now you can even describe also, sir. kubectl describe PVC and specify this PVC name. See, it will show you everything. So what is the storage class? It is my wall. Okay. What is an access mode, read write mode? What is the capacity? 2 GB. Used by none. Events none. Nothing is there. It has not been used or claimed by anyone now till now. So you can even describe and check it. Okay. Now what I was trying to tell here that actually now I want to write a application or the deployment YAML file I have to write where I can use this PVC. Okay. So what I have to do that I just I was in my Kubernetes document, right? I was into the persistent volume document, right? So here itself, what happened, right? In the search menu, I have to just type WordPress. You want to get that YAML file, sir, where you have to use the WordPress application. So I have to just press, sorry, I have to just type and I have to just say enter. So it searches, and here you could see that you will find an example of deploying the WordPress and MySQL with persistent. It says that actually. So click on this and come over here at the down. Here you will see an example actually. See here you have an example of the WordPress YAML file. If you see over here, you could see here, see API version deployment. Yeah, this is the file or this is the YAML file I need actually. So I'll copy this. So till where I'll copy, till I'll copy at the end, till here I will copy it. Okay, sir, I'll copy this. So what I'll do, I'll just say WordPress.yaml. Okay, sir. So, okay. Now, what it says that the kind is deployment. So you are creating a deployment in the metadata. You are creating a WordPress. This one WordPress name WordPress and MySQL, and here you are specifying the label. And in the selectors, sorry, in the app in the spec actually you are creating a selectors, and here also you're specifying the label as what you're specifying the label as WordPress, and you're using the strategy as a recreate. Okay, that we know very well. And if you come out here at the down actually, here you are creating a container, right, with the image MySQL 5.6 version, right, and the name is MySQL, and you have to pass some environment variable, at least one you have to pass, that is MySQL root underscore password. And basically what it is doing, right, it is trying to take something from the secret file actually. Right now we don't know anything about the secret file because we have not come to that topic of config map and secrets and all. We have not gone through it, so we'll not be able to understand this as of now. So what, okay, And we'll do the changes now actually. So, and here you could see that the MySQL is basically running on the port number 3306, right? And if you come down here, it is using the volume mount. Basically what happened, right, whatever the MySQL is there, right, it is using the volume mount point with the name MySQL persistent storage, and the mount to path is the but /var_lib MySQL. Okay, it means that actually whatever the volume is there, that will get mounted to this path actually. Okay, now here what is the volume it is using? It is using the volume with the name MySQL persistent storage. And what is the persistent storage claim? It is using the claim name as MySQL. Here you have to change the name, right, because here it is not MySQL PV claim. Here the name is what? Here the name of the PVC is what? What have the name? What is the name I have given? My hyphen volume hyphen claim. Correct? Correct, sir. If you are still having a doubt, you can just say kubectl get kubectl get PVC. You can see this my hyphen volume hyphen claim CLAIM. Same thing you have to use, sir, in the WordPress. My volume claim. Yeah. Okay, I've used the same name, right? Okay, guys. Now here what I will do, I will remove this lines actually. I don't want this line. Okay. So I'll give the name actually as I'll give some name, something Red Hat I'll give. So this is a name. This is a username and this is a password actually. Okay. So this basically you have to pass this environment variable whenever you're using MySQL. So that we know variable. We have seen even in the Docker class also. This you have seen it. Okay, guys. So now what you will do that? So this is my WordPress application YAML file. Now what I will do that? So let me first check whether any pods are there in my system. If there are no pods are there. Now what I will do that? I will apply it kubectl apply -f and specify your WordPress. Now if you execute kubectl get pods, now you could see that it has got created. You can even say kubectl get all -o wide, right? Now you could see that actually your pod got created into the worker one, and it is a type deployment, right? And you know that replica set is also got created, right? So basically what is happening is that you have got your WordPress application running, and this is a pod name. Even you can do a describe also. If you execute kubectl describe pod and specify the pod name. Specify the pod name. See here, guys, can you see here? So I have executed kubectl describe pod and specify pod name. Now you could see that your pod is up and running, and this is the pod IP address. That is fine. And if you come down here, it says that your pod is running your MySQL, and this is the environment variable. It means that basically this is a username and this is a password. Okay, it is in a running state. Fine. And it is using the mount. What it is mounted? It is mounted /var_lib MySQL from your MySQL persistent storage actually, which is having a read write actually. Correct. Now here, if you come down here, it says these are the events, sir. It says that it has created the pod, MySQL, it has started the pod also. That's what your pod is now up and running. Clear, sir? Now, if you execute the command kubectl get pods, it says that your pod is up and running, right? So let me open a duplicate session. Okay, so let me log into it. Come into the master now. So what I will do basically, guys, I will get inside this pod actually. So to get inside the pod, you have to say kubectl exec-it, specify this pod name, and -fn /bin/bash. So see, you got inside your pod actually. I mean, not inside pod, inside the container actually. Correct? Inside the container now. So now what you will do that here, what you're going to do, you will be logged into your MySQL -user is root -password p. You have to use the password as Red Hat. You are into the MySQL. Now if you say show databases, so it says that these are the database are there. Suppose assume that you want to create a new database. What you will say? Create database India, something. So create a database. Again, you say show database. So you can see that your database has been created, right? Now what you can do here that because like your pod is running now assume that you are killing this pod actually. You can say kubectl delete pod and specify the pod name. See, you're deleting a pod. Now you see that as soon as you delete the pod, your pod got deleted. You know, here also you have break the connection. See, you break the connection because you deleted the pod itself actually. But what happened, because you're running under the deployment, it will create a new pod actually. So that's what if you execute kubectl get pods again or kubectl get all, right? Now you could see a new pod got created. See, you can make out the difference here. Earlier it was 56RJ2, now it is H4KPR. So this is a new pod, right? Because you have created the deployment, right? It will maintain the replica, it will maintain the replication, right? So it will create a replica, right? So now what is happening that here come back again, go to the same thing.
Rajesh, one question. We did not mention the replicas, right? Even that will maintain.
No, we have maintained, sir. In the WordPress, what we did, we created deployment.
Yeah, correct.
No problem. If you're not creating replicas, it has to create, right? It has to do, right? Replica means more than one if you need.
Okay.
Under the
By
selector,
default.
you need more than one you need, right? Then you can create a replicas. Otherwise, only one it will create, sir.
Okay.
If you delete it, again this deployment will recreate. That's what. If you see it here, kubectl get all -o wide. See, you are having a deployment, but you are having a replica set. This
Okay.
replica set will make sure that whenever this pod is getting deleted, a new pod will get recreated again.
Okay. Even though we did not mention the replicas 2 or 3.
No problem. Yes.
Okay. By default,
By default, it will be one. By
One.
default, it will be one. Yeah. One.
Okay, got it.
Now you can see that now this is a new pod actually got created. Again, you can do the same thing. Go back here, kubectl exec-it and specify this pod name and get inside your container actually pod. Sorry, get inside container. Now if you say MySQL -user is root and -p is a password, give the password. Now you say show databases. Still your database exists. So even though pod got deleted, a new pod got created, and again it has mounted back the same PVC, right? It has mounted back the same PVC. So that's the
Yes,
reason
sir.
you could see that this data is available. So this data is persistent. That's what we can prove, that the data is persistent. So it is not deleted. So this is the best way to showcase that how PVC works actually. Clear, sir? Yes. So now what we can do that we can delete everything. kubectl delete -f, specify your first WordPress. You're deleting the pod actually, right? kubectl get pods are not running. Yeah, one thing I want to tell you, sir, one thing very important thing which I have observed is that suppose like you created everything fine. Now you created the PV, you created the PVC, and you created the WordPress. Now what will happen that actually that if you try to do a kubectl apply -f WordPress, right? And if you execute kubectl get pods like this, what will happen, right? Sometime what happened, right? You will see that your status will be like something like container creating. It will not come up at all. Now, and if you say kubectl describe pod and specify your pod name, and you want to check what is the event actually, here at the end of the event, right? You will get this message, sir, like this. Where is it? Like you will get the message like this: mount /var libbook kubectl, like this. You'll get the mount. You can see that this is the error you are getting actually, sir. Bad option. Something like this. You will get this message. So why this is happening? Why you will get this message? Because this pod, where this pod got created, sir, kubectl get pods -o wide. Your pod is getting into the created under the worker one. Under this worker one, it is getting created actually. right? What you have to do that in this worker one, you have to install the NFS common package. See, if you see here actually, if you see into the DigitalOcean document, I think, yeah, I opened it. Yeah, in the DigitalOcean document, now you could see that if you come down carefully, if you see here, you install the package. Okay, see on the client side, you have to install the NFS common package. So what to do that? You have to install the NFS common package, sir. If you're not installing the NFS package, common package under your worker node, because here under the worker node, the pod is getting scheduled, right? Then what happened, right? It will not be able to mount that NFS drive. Clear, sir? That's the reason you will get this error, sir, actually. So that's how you have to make sure that, okay, you have to install that package in all the worker node. Suppose assume that you are having some 3 worker node or and whatever the worker node you have, right? In all the worker node, you have to install that NFS-common package, sir. This is very important, actually. This one, where is it, sir? Yeah. And one more thing, what I have to tell now, sir, this here I'm using a Ubuntu, sir, actually. I'm using a Ubuntu. Okay. So in the Ubuntu, you have to install the NFS-kernel-server, actually. The same step will not be same for every other distribution, actually. Okay, it will not be same for every other distribution. So if you go to the how to install NFS in CentOS 7. If you go to the CentOS 7, or if you go to the TechMint, right, it will be different, sir. So you have to depend upon the Google, and you have to search for the document. See, here the steps are different, sir, actually. So you have to install means you have to install the NFS package. Like here, if you come here, they will mention. See here, whenever you want to install NFS, see the package name is NFS-utils, NFS-util-lib. This you have to install it, and also you have to install the port map also. Okay, so in case of this one, in case of Ubuntu actually, or in case of a Debian, you have to install here, or else you have to install this NFS-server-package. So this you have to NFS-kernel-server. This you have to install, sir. Is it clear, sir? So what you have to do that whenever you're installing a package, suppose you are installing in CentOS or installing in Red Hat, you have to go to the you have to search for that particular flavor, and you have to see all the steps, sir. You cannot say that, oh, this NFS-kernel, it will available even in Red Hat also. No, NFS-kernel-server, right? This is applicable only to the Debian or to the Ubuntu. Clear, sir?
Yes, Rajesh.
Okay, sir. Any doubts you have, sir, till here?
So for suppose by default, if image is not there, for suppose we are pulling some image, so it that particular image does not have NFS, means it will be fail, right? That mount of that will be fail, right?
Come again? Yeah, come again.
For suppose we are pulling the images, some image, we're trying to mount volume something, that particular deployment. If NFS package is not there, will it fail?
No. Here what happened, right? Here, if you see the WordPress, actually, I'm using a MySQL, sir. Actually, MySQL image I'm pulling.
Yeah, correct.
Okay, here you can assume that you are saying that MySQL 5.6 is not there. It is pulling.
No. In the MySQL image, if NFS package is not there,
NFS. No. Here what happened? No, it doesn't require the NFS and all, sir. It requires only it only requires this.
Master node
No,
required.
it only requires the persistent volume claim, sir. That's what. See, ultimately what happened now, sir? Your MySQL, this is the container now, sir.
Yeah, correct.
Okay, this container, and this is it's running under pod, and this pod is running under your worker one. I'm saying.
Okay.
Now what is happening is that actually how the diagram comes here is that actually. Now what is happening is that actually now you see that actually that here what is happening that one of your pod has got created in worker one, correct?
Yeah.
Now you can understand, you will be able to understand what I'm saying now. Now this is a pod which is running actually.
Oh, got it.
Right. Now what happened? This is NFS. Now this NFS has to first mount to your node.
Worker node.
This worker node should have the NFS.
Okay, okay. I thought.
Once it get mounted, then automatically it can claim, it can mount actually like that. From it
Okay,
has to
got
get
it.
mounted, and finally from here it will get mounted to your pod actually.
Okay, got it. Got it. I
Clear,
thought
sir?
yeah,
Yeah,
clear.
yeah. It's a good
No.
question, sir. It is good that you ask now itself, right? Because
Mm.
how you know, right? Because it has to first mount it to your worker. Then, so to because it has to get mounted, that is the reason I was telling you that you have to install that NFS common.
Yeah. Got it.
You got it? Otherwise,
Yes.
it was failing like that. I was getting this error actually. I mean, I means actually, I've seen commonly people are getting error like this actually. See,
Okay.
if you copy this actually,
Mm.
most of the people will get this error actually. Copy it and just say Google.
Okay. So I have one more doubt. Okay.
Yes, sir.
So on-prem we have, and then as well as EKS we have, right? On-prem, generally on-prem cluster, you mean to say most of the people use the NFS server, or even any idea?
No, on premises you can use the NFS also, sir. NFS is that's what I'm saying. NFS is the most common, storage which is used across everywhere actually. Suppose
Okay.
if you are using the cloud, actually, you can use the storage class based on the cloud actually. Whatever the cloud provides, right, that you use as a storage actually. Because see, ultimately what happened, right? Your storage should also be, it has to be. See, for example, here, assume that actually here you are having, here you have created the storage actually. Now you will say that Rajesh, the storage itself is gone now.
Okay.
What will happen? So usually what happened, right? In the cloud, what they will do, right? They will create the snapshot of this, sir. Automatically they will create it.
Yes, correct.
Yes, they'll create a snapshot and they will keep it actually
Yeah.
like that. But whereas in case of your on-premises, even though you are creating NFS storage, actually, still you want to, keep a persistent of this. Actually, what you do, you'll mirror it, and one more copy of this you will be storing in some other drive.
Yes, correct.
Yeah,
So
that you have to take it manually. I'm saying. Whereas
okay.
in case of a cloud, automatically the cloud provider will do that. Actually, you need not to worry.
Okay. So in our
Or
case,
else you can
mostly.
even you can also create a mirror, and you can also create a snapshot and keep it actually. That is also possible. You as a user also can do it actually.
Okay. In our case, mostly like for NFS, we are used like NetApp or something, some other providers, right? Generally.
Correct. Yes.
Yeah. So for suppose in on-prem, for suppose in the cloud, let's take example AWS.
Hmm.
So we go for EFS volume,
EBS, yes, EBS,
E-
Elastic Block Storage, yeah.
not
Or you can go
EBS,
with
right?
EBS,
Not
yeah.
EBS, right?
EBS
The
only,
oth-
sir.
okay, okay.
EFS is a file system, Elastic File Storage, right? File
Yeah,
system, right?
yes, correct.
Yeah.
We go for EBS or EFS.
EBS, sir, EBS, Elastic Block
EBS
Storage.
only one. We can mount only. I mean,
Hmm.
one EC2 instance only, right? EFS equal to NFS, right? If I'm not wrong.
Yeah, correct. EFS is going. Yeah, correct. EFS will go through. Correct.
Yeah.
Yeah, you're right. Actually, yeah.
Mhm. Okay. Right. So that particular cloud provider is with EFS
Yes.
for AWS.
Yeah.
Okay.
Fine, sir. Okay.
Mhm.
So, okay, sir. So we'll quickly delete it everything, sir. So kubectl delete -f.
One more doubt. For suppose if already mounted value, if you try to delete that PVC, it will delete or not?
No, now it is mounted, right? If you suppose your pod is up and running, it will not
Yes,
delete, sir. Actually,
it will not delete, right? By
it
mistake,
will not
somebody
delete.
has tried to
Yeah,
remove.
it
It
will not
will.
delete, sir. Yeah, it will
Okay.
not delete actually. So here, what happened? Right? That's what you have to first remove this WordPress, and you have to delete the PVC.yaml,
Okay.
and then you have to remove your PV.volume like this.
Okay.
Yeah,
Got
like
it.
this. Yeah, like this. You have to remove, sir. So kubectl get PV get PVC. Nothing is there. I'll do one thing. I'll go here and I will terminate this because I don't need it, right? So I'll terminate this. Okay, sir. Now, so that is what today we have covered about the volume actually. So now getting back, we'll get to learn about what is an RBC. Very important thing, sir. Just give me half an hour time. We'll finish it off. So it is very important. Okay. Now usually what happened, right? Whenever we execute a command, kubectl get nodes. How we are able to see this output? You will say that because Rajesh, in your master, you have configured, you have configured your, API server, right? You have configured all your API, all the subsystem of your master, everything is running under your master node. Hence, what is happening that you are able to, execute this command. Means because as a root user, you are configured, and also like all the, like the whole setup of your master, you have configured into this machine itself. That is what you have a permission to execute this kubectl get nodes. You're able to execute and you're able to see what all the nodes are there. But actually, how it gets to know, right? If you're executing any command, what it will do, it will go to this, you know very well that under your hidden, you have one file by name cube. Sorry, you have one directory on that dot cube, right? If you get inside the dot cube, you know very well that you have something like this config, right? VI config, right? So this is a configuration file, sir. So it means that it will get to know that who is a master. It will get to know from this configuration file actually. So even you remember one thing, like when I was installing everything and even I was setting for some other user, right? I created one more user in case of Linux and I showed it, right? You have to copy this configuration file over there. You remember in very beginning of our Kubernetes class in third or fourth session, I showed you, right? This configuration file, you have to go and you have to create it there over there. You have to create the .cube directory and like that I showed you, right? So basically what you're doing there, whenever you're executing any of the commands, basically it will check under this configuration file whether this server is a master this server, whether this server is what. If it is a master, under that you will have a cube directory, .cube directory. Under that you have a configuration file, sir, VI config file. Okay. Here what happened, you could see that it says that this is the IP address. See, basically this is the IP address of your master node, as well as this is the port which has been exposed actually 6443. Hence it will come to know, okay, this is a master node where the API server is running, sir. Clear? Because of this reason itself, what is happening, that you'll get to know that, oh, okay, I am the master, I have the authority or I have the permission to execute this command, kubectl get nodes. Okay. Now what is happening, that if you open this configuration file, here it shows you that the name is under Kubernetes. Okay, the cluster name is Kubernetes. Okay, fine. The user is Kubernetes administrator, kubeadmin. Okay, he's a super user, and the context which is running is Kubernetes-admin something. It's a context. And if you come down still here, basically you have two certificates here, sir. You have a client cert data. This is one certificate, and the client key data. This is other certificate. So basically, you're having these two certificates. If you're having these two certificates, then only you can execute all these commands, sir. kubectl, get nodes, and even kubectl get pods. Any kind of a command you execute, how you are going to execute, because that you are under the .cube, you are having a configuration file. With the help of this .config, it will get to know I am the master node, or I have an access to execute all these Kubernetes commands actually. Okay. Now you could see that under the root you have a .cube directory, you have a config file. Suppose assume that if I move this config file to something like so always whenever you're playing with the config file, sir, always don't play with this config file. Always you take a backup of that actually, something. Always you take a backup of that. Backup file, sir. Always take a backup file, then only play with the configuration file. So suppose assume that I move this config file to the config one. Will it works actually? Let's see. It will work because like there is something was a cache actually. Even though you're deleting the file, till your server is up and running, it will refer to that cache, and from that cache it will get to know that it is working. Earlier what happened, this cache was not there, sir. At the time, this cache itself was not there in your previous version. Suppose you're working on v1.18. So this cache concept was not there actually. So in that case, what happened, whenever you're executing any of the command, right, always it checks under the cube whether this config file is there or not. If this is not there, that command will get failed actually, like that. Okay. So that's how. So anyhow, so we understood the concept that this config file should always be there. Correct. So now what I will do now, right? What I'm going to do now is that actually I'm going to create a user account with some name. Suppose I create a user account by name, any name. If I take, suppose if I take something like Naveen name or any name if I want to give. Suppose I create some user account in my system or in some other system, I'm creating some user account, Naveen or Rajesh or anybody. I want to give the permission to him so that whenever he want to execute this command, he can execute those commands. So what are the steps you have to do that? Okay. So what I will do here, basically, now I'll do one thing, sir. I will try to create a user account with some name. Suppose like I create a user account by name Gaurav. So let me create a user account by name Gaurav actually. So what is the command? You have to create a user account by name Gaurav, add user Gaurav. So it asks for the password. You give the password, something I'll give 123, 123 password. So enter, don't do anything, and just say enter, 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 and give Y. So you have created a user account by name Gaurav. If you want to switch from your super user, right, you can just say su-Gaurav. Now you could see that you have got into the Gaurav user account. If you execute PWD, you could see that you are into the Gaurav user account. So this Gaurav user, even though you are into the same server, assume that this is one more server where I have Gaurav user is there. He is executing the command kubectl get nodes. See, he is not able to execute the command itself because you don't have any permissions actually. So now basically what is happening now, sir, you are having you're having two sets of permissions, sir. Okay, one is, sorry, you're having two sets of permissions, sir. What's the permission? One is the part authentication. Authentication means who can enter into my cluster. That is number authentication, sir. Means he has authority, he can log into the my cluster actually. Like here in this case, we are able to log in as a root server because the root has an access to the Kubernetes cluster, hence he is able to execute the command. Similarly, I want to provide the authentication that who can enter to my cluster, that you call the authentication. The second is authorization. Means once the person has logged in, what that person can do. It means that suppose that once you're logged in, what and all you can do. Suppose like you want to create a namespace, you want to create the volumes, or you want to delete the namespace, or you want to create a deployment, create the pod, delete the pod. You want to do n number of operation into the Kubernetes, right? So what are all the permissions? What are the things which we can do after login to the server that we call as authorization? So these are two different terminologies, sir. One is authentication, one who has an access to get inside the cluster, Kubernetes cluster, that is authentication. It means that he has to have a user and password, but yes, you have to give him some kind of a authenticity so that he can provide his username and password to log into the Kubernetes cluster. That we call the authentication. Second is authorization, means what are the permissions he has so that he can play around with that. It means that what are the actions he can do, like he want to create a namespace, he want to create a deployment, he want to create a volumes and all, that we call as authorization. Clear, sir? Now here, what I'm to do, what I'm trying to tell that root user by default he has it because I've configured, I've executed the kubeadm init and all, I've created it, I've initialized it, I have did all the kind of settings and all, so that the root user has by default it has the permission to do any kind of a stuff into the Kubernetes cluster. But I have created a user account by name Gaurav. I have to give all kind of an access to him. Now what I have did here now, I have given him the authentication now. Okay, the user account is created, but still he want to authenticate into it, right? He want to log into it. It means that as soon as he is executing, Gaurav, as soon as he's executing it, he has to even execute it. But right now he doesn't have any permission, sir. How he is able to do it? How he can do it? Basically, you have to create. What you have to create, sir? You have to create the certifications you have to create. So what you have to do that, we need to generate some X509 certificates to the Gaurav, right? And we have to provide all those details to it. So now let us understand or learn how to create a certificate, sir. Now you know very well that, see here, if you see it here, under the root, we have a .cube directory. Okay, I'll get inside .cube directory. Under the .cube directory, you have something known as a config file. You know very well that this is a config file. So I need to create a similar configuration file for the Gaurav, and I have to provide under his home directory, sir. So here, if you come down here, you could see that actually here it is having these 2 certificates. Guys, 1 second, guys. Okay, guys, sorry, my daughter was shouting. So now what we have to do is that actually we have to create the same configuration file, and we have to, but here you have to create some X509 certificates and all. You have to create the certificates, you have to provide this, all these 2 certificates you have to provide, and here also some changes you have to do. Here also you have to give the name and all, everything. So basically you have to create this configuration file and you have to give it. So how to do that? So I'll be doing that process now actually. So what I will do, so let me do one thing. So let me create one directory by name Gaurav. First let me create a directory. Okay, let me create a directory and I'll get inside the Gaurav directory. Okay, so after that, now what I will do, like I will try to copy the certificates, or where I'll get the certificate, etc Kubernetes PKI, right? If you see here, you have a CA cert, CA.key. So I'll copy this C cert here. Similarly, I need a key actually, CA key file. I'll copy it here. So these 2 files are copied, correct? Okay, guys. Now I have copied these 2 files. Now what I will do next? Next, I have to create a X509 certificate. For that, to create an X509 certificate, I need these 2 files, sir. That's the reason I copied from here. Now, what I will do next, I'll execute a command, open SSL generate RSA -out Gaurav GAURV. Please make sure that the spelling is correct, sir. Okay, Gaurav key, and specify this 2048. See, it has created a file with the name Gaurav.key. Okay, next step, open SSL req -new -key -new -key. What is Gaurav.key -out. Basically, the next step is that I have to create a CSR. CSR means certificate signing registry, signature registry. CSR file you have to create. So that's what you have to run this command. But while executing this command, sir, open SSL ric -new -key Gaurav.key -out Gaurav.csr file, certificate signature registry. That's what you have to create. In most of the companies, you know that automatically you have some tool to create the CSR file. You'll generate and you will create that file. But here I'm creating it actually. So you have to just run this. It'll ask you the country name. Don't give anything here. Just say enter. Just say enter. 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 Here what is happening, that here you could see there's something as a common name here. It is asking. Here you have to give the name here. Gaurav I have to give. That's all, sir. This is the only place you have to give the name, sir. Okay, no other place. Don't give any name here. You just say enter, enter, enter. Now you say enter, enter, email ID, challenge the password, enter, enter, and you could see that you have created a Gaurav.csr file. Till here, are you clear, sir? So why I'm doing all this test? I'm creating a certificate, sir. So what is the first step I did, sir? First, I copied this file ca.crt. Under that, firstly I created a Gaurav directory, sir. By using mkdir command, I created directory. Under the directory, I need these 2 files, ca.crt, ca.key, because like I want to create the I want to create the key as well as I have to create the CSR. For those 2 things, I need these 2 files, sir. So here, after this copied, you have to run a command, open SSL, generate RSA key -out Gaurav.key and specify 2048 actually. Okay, and after that, here you have to specify a command, open SSL ric new key Gaurav.key, whatever you have created -out Gaurav.csr. Here you are creating a CSR. While creating it, it'll ask you certain things. Don't give anything. Under the common name, you have to give the name Gaurav, and you have to say enter. You have got created with the name goro.csr. Till here, are you clear? Clear, right?
Yes, Rajesh.
Okay, sir.
Yes, Rajesh.
Now you have to create the X509 certificate, sir. X509 certificate how to create, sir. This is a certificate I have to create it. So let me clear my screen. How to create it? OpenSSL, same command, sir. OpenSSL X509 -RQ request -IN. You have to give the gorob.csr file -CA. What is the certificate? CA.crt. That's the certificate. CA key. What is the CA key? We know that we are already having CA key in our current word directory. -CA. CA. What is it, sir? CA. Create serial. Yeah. Create serial. -out. Gaurav dot crt. Okay. -days. 365 days. Basically, I want to create a certificate for 1 year, 365 days. So when I enter, you could see that a file by name goro dot what is it, sir? You got created, right? Goro.crt. This got created, right? File got created, right? Clear, sir? So this file you want to have a CRT file. That's what. Now, if you execute the file command onto this, it will show you that this is the PEM certificate actually. I think I can even give the cat also, cat of this .crt. This is a certificate, sir, actually. Clear, sir, till here?
Yes, Rajesh.
Okay, great, sir.
Yeah, got it.
Yeah. Now, what is happening that because here you need a Gaurav dot you need a Goro.crt and then you want it actually. You don't need other files, sir, actually. You can remove these files actually. So what you can do, you can execute, you can run CSR, you don't need it. You don't need it CART, you don't need it CA dot, what is it? CA dot Kia. Okay, what else is there? You don't want these files actually, and you don't want even the CA dot SRL. You want only these two files, sir, actually. So you can even remove CA dot SRL also. So now you could see that you are having these two files actually. Okay, so now what you do that? So you are already under this Goro directory. So now what I will do that under, you know that under the root, you have a .cube directory. Under that, you know, there is a config file. We saw that. Just try to copy that file here. So you copy this file here, config file. Okay, you copied that config file here. So what you can do, you can open that file, config file. Sorry, excuse me. Here you have to do the changes, sir, actually. So here you have to give the changes here. User is Gaurav here. Okay, the username is Gaurav here. So here you have to be little careful, sir, while giving Gaurav here. Okay, and the current context is something like Gaurav context. Don't have to give anything else here. You can give some name, Gaurav context, Gaurav hyphen context. Here also the name you can give as a Gaurav. What else? Here also Gaurav we can give. Sorry. Okay, so make sure that here at the end there are no spaces, sir, actually. That you make sure here. See, there are no spaces over here. If there is some spaces over here at the end, right, it will give some trouble actually. Now after that, basically you could see that you are having some certificates here, client certificate data and client data, sorry, client hyphen data, client key data and client certificate data. So what you can do here that you can copy this this one, sir. You can copy this, and what you can do, and just paste this, and you can remove this line actually. Similarly, you can copy this. Okay. Paste this, and you can delete this line. Now what is happening that you want to have this certificate as well as a key actually. So save this file. Now you could see that actually you are having a two files, goro.crt and goro.key. So I want to copy this. This is a certificate actually, but it is not under the base 64. So what you can do, cat goro.crt pipe it to base 64 -w 0 you can give. So what is it? Cat base 64 -w0. Yeah, I gave who actually, that's what -0 you have to give, -w0. You have to copy this one, sir. Copy till here, sir. See, equals till here. You can see equals here. Copy till here. Open that config file. Come here. Go to the insert mode and then paste it here like this. Here, sir. Similarly, and save this file. Similarly, what you have to do that you are having a key file, goro.key. Sorry. Base 64. You want to basically have a base 64 format. That's what you have to use. So pipe it to -w0. So this is the key. Copy this till here. Till here. Open the file, config, and come over here. Go to the insert mode, give one space, and paste it. Here, sir. So you have copied both this certificates. You have copied it. Now save this file, sir. Save this file. Now what happened, right? You have the configuration file for this Gaurav, sir. So now what you have to do that actually, you have to copy this config file. So what you can do now here, I can switch over here itself, or else what I can do that I can, because Gaurav home directory and the /home Gaurav, right? See, if you do a switch to the Gaurav, so what is there? Gaurav home directories /home, right? So what you can do is that actually you can better copy this config file under the /home Gaurav. And you do one thing, you even change the ownership also. Change the ownership also. Clear, sir? So now what happened that you have copied it, this file config under the Go home directory, and then you have even changed the permission. You have to use a chown command to change the permissions. Now you switch to the Gaurav user account. Now Gaurav user account, already this configuration file is there. Create one directory, .cube directory. You can say chmod -R 777 cube, or else .cube, or else first copy it, sir. CP, or else move this file, not copy, move this config file under the cube directory. Okay, now you could see that under the cube, you are having this config file. Here, sir. Now you try to execute the command kubectl get nodes. Here, what is the error it is saying? Error from the server. Node is forbidden. User Gaurav cannot list the resource node in an API group at the cluster scope. So he got the authentication, but authorization he has not got, sir. Got it? He has not authorized to execute this command now. Okay. Now what he has to do now actually? So what we have to do now, you have to provide the authorization to him. So what is authorization? How we can provide authorization means you have to provide the authorization. So here what is happening is here. So authorization is maintained by RBAC, sir. Here in this case you have to specify RBAC. It is maintained by RBAC actually. RBAC is basically one of the resources. With using this resource, Kubernetes resource, you can provide a permission to specific users actually. Okay. So So we know very well that RBAC is nothing but role-based access control. Okay. Now here, basically what is happening that here you are having two types of roles, sir. What are those roles? There are two types of roles are there. One is a cluster role, sir. Cluster role, and other is a project or local role actually. Okay. Now what is cluster role basically? Okay. In the cluster means cluster means in the cluster level actually. Here what is happening is that here also you are having a two sets of roles actually. One is a cluster admin. Okay. So if we attach this role to someone, that person will have the root access on the cluster. So what it means that suppose here for the Gaurav user, if I'm giving the cluster role, under the cluster role, I'm assigning the role of cluster admin, no, he will act as a super user. Because whatever the root user is doing, right? The root user is doing the same operation, even Gaurav can also do it. So that is very dangerous, right? You should not always give any cluster admin permissions to any kind of other users, right? You will not be giving, right? So what is the other, apart from this, what is happening that the second one, what we are having is a self-provisioner actually. What by self-provisioner? Under self-provisioner, user with this role can create namespace and delete them. So it means that they will get a very limited, very limited permissions where they can create a namespace, delete the namespace. Few of the operations they can do. Okay. So that is one part. That is one role. And second role is nothing but the project or the local role. So this is under the project level, sir. And if you come to the cluster role, this is under the cluster level actually. Okay. Now here under the projector or under the local role actually, basically you have some permission, like we have some view permissions, like person with this role can see all the resources inside a namespace. It means that he can only have a view permission actually. Suppose I want to see the pod, I want to see the resources, I want to see the volume. He only has a view permission. Like in the command, right? Kubectl get pods, kubectl get PV. We use the get command, right? So get command, what will do? It will only view it. It only shows. So only the view permission only you can. Suppose like you say that Rajesh, I have created a Gaurav account, and for the Gaurav, I'm giving a project level, and that too I'm only giving a view. It means that he can only view it. He cannot do editing. He cannot do any other action onto the resource. So that is what nothing but view role. Similarly, we have something known as a edit role actually. Person with this role can create, delete, modify, patch, anything, patch the resources. He can do any kind of operation, but person can't give someone else permission. It means that suppose the user edit is given for the Gaurav user, he can do all these operations, sir, but he cannot give some other person. He cannot give permissions actually, because if he want to give, he has to be a cluster admin actually. But here under the project level, he can do anything, but he can't give the permission someone else permissions onto the namespace, and can't even manage the quota, resource quotas and limits. This is the limitation, sir. Or whenever any person is given a project level edit, right? He can do all this operation, but he cannot give some other person he cannot give permission to that particular namespace, as well as he cannot manage any quota or limits. And third is that you can give an admin actually. Under the project level also can give admin. So person with this role can do anything within that namespace. Okay, sir. So these are the two types of roles, sir. Just a second, sir. I'll have water. Okay. So coming back to here, so there are two types of role binding, sir. You want to bind all these roles, right? So there are two types of role binding. One is a cluster role binding. Cluster role binding. It means that suppose you are attaching the cluster role binding to any user, actually, he will get the cluster role. Similarly, in the project level or into the local role, if you are attaching any user, he will get the role binding. Actually, these are two different, sir. Cluster role binding and role binding. For the cluster role binding, you can even check with the kubectl command, kubectl get role binding. Like this, you can check whether what are the users who have been given what are the users who are given attached with the role binding, with specific role binding. For here also, what you can do, you can say kubectl get cluster role binding. You can check it like that, actually. Okay, sir. Now, okay. Now what you can do that here, come back to here. So I think this I will remove it. You are having a master. Okay, fine. Here you are having a Gaurav. Okay, let me do one thing now. So I'll say kubectl get nodes. See, Gaurav is not able to execute it. Now I want to give him the I have to give him the cluster level no role binding permission. I have to give him so that he can view it. So how to give that? Here you can come back to your master. You can execute a command kubectl create cluster role binding binding, and you can say -FN help, and you can say pipe it to less. So you could see that you have a command kubectl create cluster role binding. So you can just copy from here, and then what is happening that you can paste it here. So what you can do, so who is a user? So Gaurav is a user, fine. So here you are giving a cluster role, here giving a cluster admin, sir. This is the full permission you are giving. And here what happened, kubectl will create cluster role binding. Here you have to give the cluster role binding name. So what I will do here, the name I will give as a something like a Gaurav1, something. Gaurav1. See, I have given him the permission. Now the Gaurav, you see, kubectl get nodes. See, now he is able to see it. I don't want to give him the permission. I want to delete it. Similarly, kubectl delete cluster role binding. So deleting it, sir, right? You want to delete, you have to say delete it. Now you see, go back to the Gaurav. See, he will not be able to execute the command. Till here, are you clear, sir?
Yes, Rajesh.
Yeah. Now, so I have removed it. Now, basically, what happened was, sir, here you have given the cluster admin, because if you give the cluster admin, Gaurav can do anything actually. So okay, now you can even say kubectl get the cluster role binding. Suppose you give this command, sir. So we are giving the command. We can even say kubectl get cluster role binding. You get many of the things. Here you will see that actually even Gaurav1 is given a cluster role binding, sir. See the cluster role binding. He has given that as a cluster admin itself, actually. Okay, so that's the reason you can even delete it. Actually, if you don't want it, you can say kubectl deleted cluster role binding Gaurav. Delete it. Actually, you have deleted it. Now, if you see kubectl get cluster role, actually, if you execute the cluster role, sir, you could see here that. See, you could see here that, sir, you are having what you can do basically. Yes, these are permission, but I was saying kubectl. Yeah. So if you execute the command kubectl get cluster role, actually, sir, here it will show that who are all the users are there, sir. Like you have admin, you have a cluster admin, edit, you have many of the resources, right? So I want to describe this cluster role binding, sir. Cluster role, actually. So you have a kubectl cluster role. So how I'll do kubectl describe bscrib and specify cluster role and specify the name cluster-admin. We have seen, right? So you could see that actually what it says that for any star any user or any resource, not user, sorry, any resource, you can give any verbs or nothing but any action you can provide. What are the verbs means? You saw, right? I can even create the resource. I can even delete the resource, right? What else you can do? You can edit it. You can list it. You can patch it. You are doing so many operations, right? All those operations you want to allow for any of the user, right? The verbs you have to provide it as a star, actually. Okay. Even you can say that kubectl. Okay. So this is what you have to give, sir. So this is what the cluster admin means. It means he has given all permission. Suppose assume that for the Gaurav, I have given all the cluster load. Already I gave, right? Earlier I executed a command, right? To give all the permissions to him. So he will get all the resource. He can have an all action. He can work on it. So he has given the complete root privilege, actually. So suppose if I say kubectl describe cluster admin, suppose I want to give him the view, actually. I'm just saying a view, actually. See, the view means what it is happening here, right? All these resources, suppose any user he's given the cluster as a view, he can only do some operation like get, list, and watch. He can use a get command. So like for example, kubectl get node, kubectl get pod, he can do get. He can even do a list and he can even run a watch on that, actually. So for all these resources like binding, config maps, limit ranges, namespaces, he only has the limited permissions, actually. Suppose he is giving, so these are all the resources, sir. This is what all the resources are there, right? These are all the resources. You know that replica set deployment. For that, if any user is giving the view permissions, right, onto the cluster role, he will get only the limited access. Similarly, if he says that actually I'm getting a edit role, actually, we're giving edit role. See here, for some of the resources, right? For some of the resources like config map, get list, he has all these permissions: create, delete, data collection, delete collection, patch, right? Updates, everything he can do, sir. But whereas here, if you come down here, for certain things like resource quotas, limit ranges, he don't have the create option. He don't have create option or delete option. He has only has a view option or the watch option, like get, list, and watch. So this is one. This is for the edit, actually. Similarly, if you say kubectl describe edit, and if you say admin, sir, sorry, if you say admin, see for the admin also he can do many of the operations in many of the resources like create, delete, patch, update, and everything. For some of the things for resource quota, for the pods and all, he don't have to do. He cannot have much of the permission, even though his cluster role is an admin, actually. So this you have to understand, sir. Now what I will do now, I'll do one thing. I'll go to the master. Okay. I'll go to the master. Now you could see that Gaurav is not able to execute the kubectl get nodes. Fine. Now what I will do that I want to create some deployments, sir. Assume that in the master I want to create a deployment. So I'll do one thing, sir. I'll create a deployment under some namespace. So let me first create a namespace. Kubectl create namespace and specify the namespace, something like my namespace, actually. So you create a namespace. You can even say kubectl get namespace ns. You could see that you have created your own namespace. Now let me do one thing. Let me create my deployment. Kubectl create deployment. Okay, what is the deployment I'm creating? I'm creating an Nginx deployment. Means deployment name is not but Nginx. What is the image? Hyphen image is equal to Nginx. And where you're creating under your namespace, which is the namespace, my namespace. See, you have created a deployment. Now if you execute kubectl get all -n, specify your namespace, my namespace. Now you could see that your deployment is up and running. Right? This is a command line. You can create a deployment in this command line like this way. Right, sir? Clear?
Yes, right.
Yes. Now, if the Gaurav user, he want to just say kubectl get all -n. The namespace is my namespace. Do you think that he is able to execute this command, sir? See, he's getting what he's getting. Formidon. He's not able to run this command, sir, because you don't have the permission itself. Correct. Now I have to give him the permission. I'm sorry, sir. I think I executed. What is the command I executed? kubectl get all. Yeah, get all -m namespace. Yeah, he's getting the all forbidden, sir. So I have to give the permission to the Gaurav so that when he's executing the kubectl get onto my namespace, right, which is created, right, so he can execute it. For that, what he has to do here? Go to the master node. You have to execute the command kubectl. Sorry, today, sorry, the class got extended, but okay. So I have to give him some kind of a role binding. So you have to say kubectl create role binding. I'll do one thing, sir. First, I will not execute this command. I'll just say -fn help and pipe it to less side. Okay, I'll copy this one, sir. Here I'll copy it. So I'll do one thing. I'll just paste it. So what I will do here, I will give the role binding as who is the user, sir? What is the username? Gaurav. Okay. What he is a create role binding, and here you're giving admin. So I don't want to give the name as an admin. So I'm giving the name as a Gaurav1. So that is a role binding name I'm giving, Gaurav1. And also I don't have to give him an admin actually. I want to only give the view, because if you give an admin, he will get all permissions, right? You have to only give the view actually, like this. And what is the namespace you have to give? -n, namespace is my namespace. See, you are giving to that specific namespace, like this. Now if you come over here, and if a Gaurav user is executing this command, see, now he's able to see all the pods deployment running under the namespace actually. Great. Now if you delete it, you know that. If you delete it, now if you execute kubectl get role binding and specify the namespace, my namespace. Now see, he's a user. So Gaurav1 user cluster role. See, he's only given the view. That's all. You want to delete it, you can say kubectl delete role binding, like that. Like for example, now he has given a role binding. Okay, now what Gaurav will do now, sir? Gaurav knows that actually, okay, this is a deployment actually. What he will do now, he is nice, he's very clever now. He'll say kubectl edit, he will give, specify the deployment, like the deployment name is Nginx, right? He will think that, okay, let me edit it. Let me edit this Nginx actually. Deployment Nginx, and he knows the namespace as my namespace. He'll come here at the down. He will see, oh, okay, there is replica 1 is there actually. So there's a replica 1 is there. Oh, let me do one thing. Let me increase it to 4 actually. Like this, he will save. He'll try to save that file. See what he gets error. See, Gaurav could not be patched. The deployment is forbidden. Gaurav cannot patch it. He cannot do it because he's only having a view permission, sir. He's only having a view permission. Suppose he is deleted. kubectl delete role binding and say Gaurav1. Now he's given the permission. Role binding, what happens, sir? Okay, sir. I think I have to give the complete one. Sorry, sir. You have to give the namespace also, right? -n namespace is my namespace. That I missed it actually. Right. Now it is deleted. Now you are creating again role binding. Here instead of view, you are giving edit actually. You're going to edit. Now what happened, right? He will come here. Now Gaurav has given an edit option. He will edit the deployment, code the end, go to the replicas. See, now he can save that file. See, he has got the edit permission. Clear, sir?
Yes, Rajesh.
Yes. In this way, sir, you can manage the permissions for the user account, sir, this way. So this is in the command line, sir. If you want to do it in a YAML, actually, you have to go to the document, actually. So what you have to do that? You have to say RBAC Kubernetes. RBAC is supporting Kubernetes or using RBAC authorization. You have to go here and you have to create a YAML like this, sir. You have to create a role like this and you have to follow what is the API group you are giving, what is the resource you are giving, like for the pods or else for the nodes, like that you have to specify, and what is the action you want to do. You want to do a get, watch, list, like this. You have to create a YAML file, sir, and you have to run that YAML file like that. You have to go through these documents are complete. This is a very good document they are given. You can understand how to create a cluster binding, role binding, and everything here under this document. It's a very good document, but it will take some time, sir. You need at least half a day to digest the whole stuff, actually. Clear, sir?
Yes,
Sir,
Rajesh.
how is this RBAC, sir? Is it an interesting topic?
Yeah, Rajesh, it's very interesting, Rajesh, actually.
Yeah. So that's
Yeah.
what we can do. A lot of things, sir, but already, like, we are already, a lot of time is, already we had more than 2 hours we have been sitting now. So I think we'll stop it now. So that, but you got the basic idea. From here you can go ahead now to further do a lot of other things.
Compared to authorization, authentication is little complex, right?
Yes. Authorization is just simple. Like, you have to create a certificates and all. But certificates and all you understood, right? Suppose you want
Yeah.
you want the commands, right? What I can do that.
Yeah. Actually, I would like to ask you,
Yeah.
please provide.
Actually, I removed that this one, right, sir? Yeah, this is what I have. But you can refer to this video, sir, to know more about. Yeah.
No.
Yeah. That's all. Okay, sir, fine. So today we are completed these 2 important sessions, Kubernetes Volume and RBAC. And in the next Wednesday, sir, we are going to start with config maps, secrets, and probes, sir. That 2 important topic we will cover, sir. And after the next week, right, next Saturday, Sunday, we have to start with the Helm, actually. Very important thing.
Okay, Rajesh. Okay.
Okay. Thank you, guys. Thank you all. And I think some of you can stop the session.
Yeah, let me do.